So here's the Unit 3 review. Simplify. First thing I recognize I need to distribute. Distribute into 4. After I do that, I want to go ahead and combine like terms. And then I'm finished. Number 3, there's nothing I can do in the first parenthesis, but on the second one, it's power to a power rule. So I need to multiply all the exponents by 3. So it becomes 2 to the third, x to the 6th, and y to the third. Now I'd want to go ahead and multiply those, so it's the same as 3 times 2 to the third, which is 8. X to the 4th times x to the 6th is x to the 4 plus 6. Y to the 5th times y to the 3rd is y to the 5 plus 3. So 3 times 8 is 24, x to the 10th, y to the 8th. Number 5, we need to FOIL the first term, so I'm going to go ahead and do that over here. I get 4x squared minus 2xy minus 2xy plus y squared. Then I'd want to go ahead and combine like terms. On the second term, I'd want to go ahead and distribute that power to a power rule. So this becomes plus 4x squared y squared. And what I recognize here is that I don't have any like terms. I have 4x squared minus 4xy plus y squared plus 4x squared y squared. And since none of those have the same variables, I'm done. Here we want to FOIL. I take the first term and I want to distribute it. Done with the first term, now distribute the second term through. And then I want to go ahead and combine like terms. Number 9, I need to FOIL this second part. Then go ahead and combine like terms. So 4x plus 5x is 9x. 9x minus 8x is x. I have an x squared plus x minus 40. Number 9, we have some exponent rules we need to use. We need to go ahead and distribute this 2 to the exponents on the top and to the exponents on the bottom. So when I do that, I get negative 5 squared, which is going to be positive 25. And then it's going to be a 2 times 2, which is a to the 4th. On the bottom, I'm going to have 4 squared, which is 16, times b squared. So that's my first term after I distribute into 2. Now on the second term, I need to distribute in a 3 to the exponents. So I get negative b cubed over 2 cubed, which is 8, a cubed. So I did my power to a power rule. Now I go ahead and just multiply straight across. 25 a to the 4th times negative b to the 3rd is negative 25 a to the 4th b to the 3rd. 16b squared times 8a cubed, 16 times 8, is 128. Then I have a cubed and b squared. My leading coefficients don't reduce, but I have a to the fourth and b to the third on top, and a to the third and b squared on bottom. So when I go ahead and do that reduction, I'll have 1a and 1b left on top, and a 128 in the denominator. Number 13, we have a rule that says if there's a negative exponent, to make it positive, we move it down to the denominator. And actually it can be for any negative exponent, so it's a to the negative n is equal to 1 over a to the n. If we ever have a negative exponent in the denominator, we move it up to the numerator to make it positive. So here what we need to recognize is that the negative 4 is only on the x. So if we do our rule properly, the 2 is going to stay on top because it doesn't have a negative exponent, but the x to the negative 4 is going to go down to the denominator. And then it would make the exponent positive. Number 15, first thing we should recognize that anything to the 0 power is equal to 1. So the x to the 0 just becomes a 1, which means it goes away. Next thing we want to do is distribute in this negative 2 as an exponent to the numerator and denominator. So we get 2 to the negative 2 over x to the negative 4 times y to the positive 6. Because 2 times 2, or excuse me, negative 2 times 2 is negative 4, and negative 2 times negative 3 is 6. Now I want to go ahead and simplify. So this 2 to the negative 2 is going to go to the bottom. The x to the negative 4 has to move up to the top. And the y to the 6th is going to stay on the bottom. So we use our power to a power rule and our negative exponent rule, and we should get x to the 4th over 4y to the 6th. Determine whether the following statements are true or false. Well, the first thing we need to do on the left side is bring that x to the negative 2 up to the numerator. So it becomes x squared times x squared. Remember, this right side we're just verifying. So we don't do anything to the right side, it just stays the same. X squared times x squared is x to the 2 plus 2, which is x to the 4th. And x to the 4th is equal to x to the 4th, so this particular statement is true. Here we want to distribute in the negative 1 to the exponent, so it becomes 3 to the negative 1, x to the negative 1. The right side just stays the same. And so because of our negative exponent rule, we move the 3 to the bottom and the x to the bottom. And as you can see by our negative exponent rule, this proportion is equivalent. So this statement is true. Now, I was using the power to a power rule, but actually, since this is in parentheses, we could have moved it down to the bottom right off the bat. Number 21. Since we have this negative exponent on the outside, we could just send it straight to the bottom, which means this is 1 over x to the 6th to the 2nd power. And then we would do our power to a power rule. So this is 1 over x to the 6 times 2, which is 1 over x to the 12th. And 1 over x to the 12th does not equal x to the 4th. So this statement would be a false statement. Those two things are not equivalent. Here we want to do long division of polynomials. So to do that, we first asked ourselves, what do we multiply x by to get 3x squared? We multiply by 3x. I put the 3x over its like term, so I put the 3x over the 8x, and then I go ahead and multiply. 3x times x is 3x squared. 3x times 2 is 6x. Then we want to multiply it by a -1. And if you remember the rules of division, basically, you just want to change these signs so they both become negative. 3x squared minus 3x squared is going to be 0. 8x minus 6x is 2x. Now I want to go ahead and bring down this positive 7. And I want to do the same thing over. What times x gives me 2x? That's a positive 2, so I want to multiply everything by 2. 2 times x is 2x. 2 times 2 is 4. These are both positive, but since I want to subtract, I change both of these to a negative. Switch the signs. Positive 2x and negative 2x is 0. 7 minus 4 is 3. And since there isn't any more numbers to bring down, 3 is our remainder. So anytime we get a remainder, we want to add it over x plus 2. Whatever we divide by, we want to put on the denominator. So that would be our answer. Number 25. What we need to recognize on number 25 is we need to add in a plus 0x because there isn't an x to the first power here. After we add that in, we would then go ahead and do our division rules. So what do I multiply x by to get x squared? I multiply x. So I want to put that x over the 0x. X times x is x squared. X times -3 is -3x. Then I want to distribute in the negative, which means change the signs. X squared minus x squared is 0, and 0x plus 3x is 3x. Bring down the -10. Now what do I multiply x by to get 3x? It's a positive 3. Then I would go ahead and multiply. 3 times x is 3x. 3 times -3 is -9. But since I want to subtract, that means I want to change the signs. So 3x minus 3x is 0, and -10 plus 9 is -1. So we want to take our remainder and add it. So this will be -1 over x minus 3. But be aware that this answer right here is equivalent to x plus 3 minus 1 over x minus 3. Since it is a -1, we would typically put the minus 1 over x minus 3, but be aware that those answers are equivalent. Number 27, we want to factor completely. What you need to recognize is we have something called a difference of squares. If we have two perfect squares but they're being subtracted, we could factor it as a plus b, a minus b. But we don't have something that's called a sum of squares, so number 27 is not factorable. We can't factor a sum of squares, but we can factor a difference of squares. Number 25 are two perfect cubes. So we want to do cubic factoring. To do that, we start off with a short parenthesis and a long parenthesis. Then we use our SOAP rules, which means same sign, opposite sign, always positive. A and then a b, a squared, a times b, and then b squared. So we want to take this particular cubic and factor it. So we want to use SOAP. It's the same sign, the opposite sign, and then always positive. We want to take the cubic root of 8x cubed, which gives us 2x. Then we want to take the cubic root of 125, which is 5. So that's my a and that's my b. A squared is going to be 4x squared. A times b is going to be 10x. And then b squared is going to be 25. So here, what we see is that we have two terms. Both of these terms have a c minus d. So we should be able to factor out a c minus d. When I factor out a c minus d, I'm going to be left with x plus 3. Here we have a trinomial. It doesn't look as if there's a greatest common factor, so what I want to use is guess and check. Since the second operator is negative, one of these is going to be plus and one of them is going to be minus. To get 8x squared, or to get an 8, it's either going to be 1 times 8 or 2 times 4. To get 3, it's going to be 1 times 3. So these are the values I need to use to try to factor it. If I exhaust all my options and I'm unable to get the right factorization, then it would be prime. But let's go ahead and try. I'm going to go ahead and try the 2 and the 4, so I'm going to have 2x and 4x. And then I'm going to attempt to use the 1 and the 3. Actually, there's only one choice, so 1 and 3. Now let's go ahead and make sure that this works. 2x times 4x is 8x. That's why I chose it. 1 times negative 3 is negative 3. That's why I chose it. So now we really just do the inside check. We multiply the inside, which is 4x. Multiply the outside, which is negative 6x. When I add that up, I get negative 2x. So it didn't work with the 1 and 3 in that position. So the next thing I want to do is maybe flip the 1 and the 3. See if it works that way. So I'm going to put the 3 first and the 1 second. Now when I multiply the inside, I get 12x. Multiply the outside, I get negative 2x. When I add that up, I get positive 10x. And since positive 10x is what I wanted for the middle term, this is the proper factorization. Guess and check method. Number 35, another guess and check method. Since the second operator is positive and the first one is negative, then both of these have to be negative. To get 4, it's either 1 times 4 or 2 times 2. And to get 9, it's 1 times 9 or 3 times 3. One thing that you should recognize is that anytime the first coefficient is a perfect square and the last coefficient is a perfect square, you want to try 2 and 2 and 3 and 3. Typically, 90% of the time, or a large percent of the time, those are going to be the numbers you want to use. So we want to use 2x squared and 2x squared because 2x squared times 2x squared is 4x to the 4th. And then 3 times 3 to give me the 9. Now, so I made those choices to get my outside terms, so I know those are good. Now we just want to double check that we get our middle term. So negative 3 times 2x squared is negative 6x squared. Positive 2 times negative 3 is negative 6x squared. And since that gives me a negative 12x squared, I know that this is how you factor it. And again, you might want to be aware that on a test, your answer could be written as 2x squared minus 3 times 2x squared minus 3, or it could be written as 2x squared minus 3 to the second power. Number 37, what you have to see here is that the first term is a perfect square, and 36 is a perfect square. And since this is a subtraction, we can do a difference of squares. Difference of squares, we want to do 2 parentheses. One is plus, one is minus. The square root of the first term is going to be x plus 7. So we want to substitute that into the first term. And then the square root of the second term is 6. So now we have x plus 7 plus 6. We always want to combine like terms. Then we have x plus 7 minus 6. So when you combine like terms on that second parenthesis, you get x plus 1. So the answer is x plus 13 times x plus 1. We also did these problems as a w substitution back when we did this particular chapter. And so if we're going to do a w substitution, what we would do is take our original equation and we would rewrite it as w squared minus 36. It's kind of easier to see how to factor w squared minus 36. It's w plus 6 and w minus 6. But after we would do that factoring, we would take the x plus 7 and we would plug it back in for the w. And again, when we combine like terms, we would get the same answer.